Hello everyone, topic for today is color and additive master batches, extending the boundaries. Before we get on to the topic, I'd like to introduce myself and our company. My name is Hemant Minocha and I have a master's degree in plastics engineering from University of Massachusetts Lowell and a polymer engineering degree from MIT Pune. I have over 15 years of experience in the plastics, compounding and extrusion industry. About my company, Rajiv Plastics Limited has been in business for over 32 years and we have two plants. One is in Pune and the other one is in Chakan, and we've been involved in color and additive master batches and specialty compounds and engineering plastic compounds for the plastic industry for commodity applications as well as for automotive applications. Let's get on with the topic, which is color and additive master batches, extending the boundaries. As I mentioned, our company is over 32 years old with factories in Pune and Silvassa and R&D facilities in Mumbai, Pune and Silvassa. We have over 200 people working for us with a monthly production capacity of 2,500 metric tons, and we have exports to over 32 different countries worldwide. Some pictures of our plant. We have 19 extrusion lines, many super compounders, mega compounders, twin screw extruders, lab twin screw extruders, Banbury mixers, as well as single screw and lab single screw extruders. Some more pictures of our shop floor and warehouse, pictures of our lab facilities. And these are the products that we make, master batches for all engineering plastics. These are all resin-specific engineering plastic master batches and commodity plastic master batches. We also make a number of additive and special effect master batches, starting from the basic UV stabilizer and antioxidant master batches to biodegradable master batches. In special effects, we have everything: transparent colors, translucent colors, pearlescent, fluorescent, glow in the dark, double color, and also edge glow and thermochromic master batches. In the compounds, we have pre-colored engineering plastics, toughened and heat stabilized nylons, ABS and acrylic compounds, mineral filled plastics, glass filled plastics, flame retardant materials, and TPO and IP skin compounds. Getting back to the topic, what are master batches? They are highly concentrated color or additive carriers which have to be let down at a certain ratio which has been set by a master batcher to improve the properties of a molding or an extrudate. What kind of master batches are there? There are two types: additive master batches and color master batches. So, since we're talking about master batches, we have to have an analogy who you should go to for a master batch. For a common thing like a cold or a flu, you go to a general practitioner or a family doctor. But when you need something specific, you have a specific ailment, you go to a specialist. Same way, when you want a certain product performance and a process optimization, you need to go to an all-rounder or an expert or an experienced specialist, who knows what he's doing about master batches. Because master batches are the miracle workers for plastics. Also, in a master batch, you need to understand what a let-down ratio is. This depends completely on the economics, the size of part, the size of the machine that the part is going to be molded or extruded out, and the dispersion requirements of the part. A master batcher may tell you to let down your master batch at 1%, 2%, 3%, or even 4%. But this would all depend. If your part is large, I would recommend something that's a 1% master batch. But if it is a small part, to improve the level of distribution, as you can see in this slide, 4% would actually mean 4 granules for every 100 granules, approximately. So you need more distribution in a smaller part. So you would require a 4, 5, 6% sometimes for a small part. On the other hand, if the part is big, maybe like a chair or a bumper, you may actually go down to 0.5 and 0.6%. So what is the manufacturing process like for a master batch? How are they made? The most commonly used machines are intensive dry mixing, internal batch mixers, single screw compounding, twin screw compounding, and reciprocating single screw extruders. Also, there are continuous mixers. I'll show you some pictures in the next slide. You can see on the extreme left, there's an intensive batch mixer or a Banbury type mixer. On the right, you can see a continuous mixer. And on the bottom, you'll see the workhorse of master batch manufacturing. That's a twin screw extruder. Most of the master batchers, they use twin screw extruders to get good outputs and a whole range of possibilities when it comes to materials, because twin screws are very versatile for most materials, starting from your basic polyethylenes to your polyether ether ketones. Another schematic of the master batch process, you can see going from the top, you have the feeding system going into the processing section where from many multiple inputs, it's going into, the material goes down to the processing section where material can be fed from the feed throat as well as from further down the line. And after that, there's a pelletizing section, and then it moves on to the discharge section and the collection part. Here's a little video on how the process looks like. We can see how the material is falling into the feed throat and the side feeder, and then it goes on as strands and it is pelletized into small granules. So like I said, the manufacturing can be a single stage process, two-stage process, or a three-stage process, depending on the equipment and the complexity of the formulation. A high concentration of the pigment or additive can be created using co-rotating twin screw extruders, like I mentioned in the previous slides, or even a reciprocating single screw extruder. The material can be split feed or it can be a premix. By split feed, I mean it can be fed partially through the main feed zone and later through a side feeder. We move on to the actual part of the topic about some new age products in master batches. There are high filtrability master batches for demanding applications like BOPP film and other films. I call it highly demanding because the cross section of these both applications is very low. And also for fine denier fibers. Again here, the thickness is very less and you want to end up having a perfect product without any line breakages. Also there are resin specific master batches for various materials, nylon for nylon, polycarbonate for polycarbonate, and polypropylene for polypropylene. Special effects in double colors. Sometimes you want your part to look like a pearl, something that has a pearl finish, or something that looks like a metallic finish. That's where special effects come in. Or you want some part to glow in the dark, so that when you walk into a room in the night, you can take a look at it, you can see it glowing and just pick it up. Double colors, you want your plastics to look like wood or to look like marble. So we can introduce an effect where you can have black lines going through brown to make it look like wood. We can have black lines going through white, making it look like marble. In additive master batches, there are things like shelf life enhancers or shelf life extenders. And then there are antimicrobial master batches, which tend to prevent algae and fungus and microbes to come on, say, your toilet seat or your chopping board. There are nucleating and clarifying master batches, which can make your polypropylene plastic look more and more transparent, or your polyethylene look more transparent. The UV stabilizer master batches, which can be used for agriculture in greenhouses. And as we go down the slides, I will be talking more about these applications and these master batches. There are VCI master batches, and nano is now the buzzword, so there are nano master batches also. And then there are biodegradable master batches, because we want our bags to be biodegradable and our plastics to be more and more biodegradable. So, like I mentioned, we'll talk about color master batches and then move on to additive master batches. So the color master batches are highly loaded with organic and or inorganic pigments to give them a specific color. There are 4 types or methods of color master batches. There are universal master batches. Same master batch works for all materials. That's a universal master batch. Resin specific master batches. An example for that would be you have a PET based master batch for PET, polycarbonate based master batch for polycarbonate, nylon based master batch for nylon, etc. There are liquid based master batches or liquid master batches wherein the carrier is a liquid. The carrier for the pigments is a liquid. And then there are particulate master batches which are more like compressed powders. They're strong compressed powders, but they're very, very highly concentrated. We move on to white master batches. The reason I'm specifically talking about white master batches is there are various ways of getting to a white master batch. There are not too many pigments that would give you a white color. There's titanium dioxide, which could be coated, uncoated. Again, that would depend on the end application. If it's an uncritical application or non-critical application, you could use an uncoated titanium dioxide. There are barium sulfates, there's lithopone, there's barytes. And like I said, depending on the end application, we could use either of these pigments, white pigments, to get a white effect in the end. So why do we need high filterability master batches? I mentioned that this is one of the new things. The importance of someone to keep their machines running continuously without a break is paramount. I wouldn't want to run my machine, say, for a few hours, open it, clean it, and put it back again. Especially, this becomes especially paramount and very important for applications like fiber or a non-woven fabric, wherein the machines are so large that cleaning itself takes a whole day, or maybe sometimes 2 to 3 days. Such customers would like to run their machines for 15 days to 18 days continuously. High filterability gives them the advantage of running it for so long. Their filters don't choke. As you can see in this diagram, the process shows a filter, a pump, and a die. The die is the spinneret. Here in the non-woven process, it comprises of thousands of micron size holes, to give a very fine linear fiber. If the filterability of this master batch is not so good, what happens is these spinnerets or the holes get choked, and the customer would have to open the spinneret and then put it into a fluidized bed, and you're trying to get it cleaned up. Again, a long drawn process. Similarly for, say, blown film. If you're making a blown film, you don't want your die to be opened regularly. You want it to run for a few days before you open it, or you don't want to bring out the breaker plate after the extruder. You want it to run long. So basically, a low filter value also means better dispersion. If you're able to bake down the pigments to such a fine particle size, you're actually utilizing the pigment to its full potential. I mentioned earlier about special effect master batches. Here are some pictures. You can look at the pictures on the extreme left. Here you can see some balls. They are transparent, and they have these lovely transparent colors, which happens to be a special effect. In the middle, you can see a nice luggage with the wave effect, as the customer calls it. And this was a huge rage in Europe maybe about 6-7 years back. And on the right, extreme right, you see a double color effect again, where the plastic is made to look like wood. You see these chairs all over the country. So some of the special effects that we have are pearl effect, transparent colors, metallic effect, glow in the dark, fluorescent colors, and double color. There are lots of other things that keep cropping up. Whatever someone's imagination comes up with, we try and do that. Moving on to additive master batches, which are the real miracle workers of plastics. So what are the new miracles that are available for plastics? There are a number of new things and additives available, but what is important is the selection criteria for additives. the processing method of the end customer, the property desired, the shelf life required, the duration of the property that's required, the polymer it needs to be added to, the processing parameters, be it the temperature, the pressures, etc. that are going to be used, and the mode of addition, where it is going to be added at. And very important nowadays is the regulation and the norms to be followed, whether it is ROHS, whether it is REACH or FDA or EN compliance. And also it's very important to know how the customer is going to be testing it. Moving on to one of the new miracles, which is the shelf life extender. We call it the Keep Fresh Master Batch at our end. It's used for fruits, vegetables and flowers and even meat products. So why do fruits, vegetables, flowers and meats tend to get spoiled? See, ethylene is generated from the rind of the fruit, and this ethylene actually causes the ripening of the fruit or the vegetable. There is a microbial effect on the microbial effect, and that includes bacteria, virus and fungi, and that also causes the rotting or the eating up of the fruit, vegetable or the meat. There's also unhygienic transportation and storage conditions which cause the ripening and the fruit and the spoiling of the fruit. Our shelf life extenders are based on microparticles of nanosilver deposited on an inorganic material like a zeolite. And also it contains a combination of scavengers as well as odor absorbers. This retards the ripening and the aging by controlling the ethylene that's generated and increases the transit life. It remains unconsumed since it is an inorganic particle and constantly works as a catalyst. We've actually seen cases where the ripening completely stops at that stage. Here are some case studies with, say, there is a lady's finger or okra kept for 6 days in ambient conditions. No refrigeration was done here. You can see on the left, the lady's finger, the okra has completely got fungus, and it is also over-ripened. On the other hand, on the right, you see the okra is completely as good as new, or there's no ripening and there's no attack of fungus or microbes. Another case study, after 3 days of coriander being kept in 2 different conditions, 2 different containers in same ambient conditions. The one on the left has got fungus, one on the right is still green and fresh. Some strawberries after 5 days in ambient conditions. The ones on the left have a whole layer of fungus, while those on the right are as good as they've been plucked from the farms. Now this is a really, really big eye-opener. On the left, you see a pear kept for 5 days in ambient conditions, and on the right, you see a pear kept for 12 days under ambient conditions. But the one on the right has been kept in a bag which has the Keep Fresh Master Batch. Pear is a very sweet fruit and hence ends up emitting a lot of ethylene. And you can see a drastic difference in both the two results. What are the applications for a shelf life extender? It could be bags, could be Ziploc bags, cling film, containers and lids of these containers. We've already talked about shelf life improvement, which had a part of antimicrobial in it, wherein it was avoiding or preventing some kind of microbial activity. There are antimicrobial master batches which are either organic or inorganic. The organic antimicrobial master batches, they travel to the surface and give a very good antimicrobial effect. The maximum service or processing temperatures of these is usually less than 250 degrees. While the inorganic antimicrobials, they work through regulated ion diffusion throughout the polymer matrix. And they have a long-lasting effect. They last actually as long as the polymer part and can be processed at very high temperatures because their decomposition temperatures are much higher than 500 degrees. Applications for antimicrobial master batches are chopping board, household items, toys, white goods, sanitary applications, as well as drinking water pipes. Any application which would require human touch, or it would require any kind of sanitization, would require an antimicrobial master batch. Nucleating and clarifying master batches. Over the last few years, we've been seeing a vast improvement in nucleating and clarifying master batches. For example, the Millard NX 8000, it actually improves the clarity to the levels of PET or PVC. There's Hyperform 68L, which is also a Millikan-based product, which improves the dimensional stability, it reduces cycle time. There's Hyperform 200N, which also improves the overall nucleation activity, Hyperform 600N. And then there's HPN 20E, which is very, very good for improvement in clarity, improvement in barrier properties of polyethylene films. On the next slide, I'll show you the haze continuum of NX 8000, NX 8000 used in polypropylene. And you can see the haze levels or the transparency is as good as PET or PVC. So like I said, nucleating and clarifying master batches based on Millard NX 8000 have given revolutionary clarity to polypropylene homopolymer, polypropylene random copolymer, and has actually brought down the haze values to less than 3. The HPN 20E master batch, on the other hand, has improved the properties of polyethylene film, has improved the barrier properties, improved clarity, and you can actually go down on the levels of the LDPE that is used in a mix of LD and LLD when making a blown film. The next type of master batch is the anti-static and the ESD, or ESD is electrostatic dissipative. Most polymers fall in the range of insulating materials. That is their conductivity is between 10 raised to 13 ohms to 10 raised to 18 ohms. As you can see on this slide, you can increase the conductivity by adding additives which come to the surface and giving it some kind of hydrophilic nature, and these are called migrating antistatics, and they bring the resistivity or the conductivity, they bring the conductivity up to 10 raised to 10 to 10 raised to 12, sometimes 10 raised to 9 to 10 raised to 12. You can also further modify using certain master batches to bring the resistivity down to 10 raised to 8 to 10 raised to 10. And if you want to further improve the electrical conductivity, you can use a carbon black based master batch or a nanotube based master batch to bring the conductivity between 10 raised to 2 to 10 raised to 6. These are called electrostatic conductive materials. From the graph, you can see how the loading of a master batch, which is based on carbon black, specific conductive carbon black, it goes from 10 raised to 13 down to 10 raised to 2 when you go up to almost 50% addition of that master batch. Some pictures of where a conductive master batch is used for storing microchips as well as printed circuit boards. So why does corrosion happen in metals? Corrosion is a natural phenomenon where an electrochemical process happens on the surface of metals, where a cathode and anode is generated, and electrons tend to flow, and there is the reaction of, say, ferrous ions with oxygen ions to give ferrous oxide. So basically rust is ferrous oxide, and it's an inorganic polymer, and it contains both iron as well as oxygen, and it's even more visible on machined surfaces. Visibly, a machined surface may look very flat, but as you can see on the picture down there, the machined surface actually has a lot of serrations, and these are all areas where corrosion can happen. So how do we prevent this corrosion? This corrosion can be prevented by using a volatile corrosion inhibitor. The VCI compounds, they volatilize in a small amount and deposit on the metal surface. The metal surface that we saw in the previous slide, the serrated surface. So they form a microscopic layer which prevents this movement of electrons and the oxygen molecule to combine with the ferrous molecule, and thus inhibiting the corrosion. This VCI layer is usually only a molecule thick, and it keeps getting replenished as soon as it gets over. So this product is very widely used. Say in this picture you can see it's the door frame of a car, the whole door of a car which has been stored in it. You can put it in, you can put bearings in it and all kinds of metal parts or gearbox parts which you don't want to get corroded. Moving on to UV stabilizers. Why do we need UV stabilizers? The harmful UV rays of the sun, they tend to degrade a polymer by breaking down the molecular chains. So in applications wherever there is very high exposure to the sun or to UV rays, say like greenhouse films or crop covers or woven sacks to keep grains, anything that is going to be kept out, say you don't want your car bumper to turn white after some time, you don't want your dashboard to look a different color after some time, and you don't want it to break or start chalking after some time. So there are different chemistries available for each process. Like for a greenhouse film, it's very important to know what is going to be grown inside the greenhouse. If it's flowers, okay, which flowers? If it's vegetables, which vegetables? Whether there is going to be any pesticide use, whether how many years the greenhouse is going to be maintained or the film is going to be maintained on that greenhouse. It's very important to know what is the thickness of the film, whether it is going to be used for mulch film or actually for a tunnel or greenhouse tunnel. In PP non-woven, it's important to know what thickness, what color, and for how many years, and also what kind of machine is going to be used. For woven sacks, it's very important to know what is going to be stored inside. If it's a food grade, it's a food grain, you need to have a food grade UV stabilizer in it. What is the thickness and for how many years you want the bag or the packaging to be safe. Some pictures of greenhouses and woven sacks, both requiring UV stabilizers. Again, pictures of some UV stabilizer usage in multiple materials in car dashboards. There are some symbolic pictures also. Pictures of the AC vents, the dashboard again, and also pictures of the side trims that are there. What is really important to know is, in a car, unlike in a greenhouse film, in the greenhouse film there's only maybe polyethylene, but in a car, there's a multitude of materials that are used. There's polypropylene, there's TPE, there's ABS, there's nylon, there's polycarbonate, there's polyacetal. And the requirements are very stringent. You want the car to look the same, say, for the next 5 years. There's so many warranties, guarantees that are promised. And as we go on, we want our parts to really last that long. So, or there are automotive companies that have increased their requirements from what they were earlier, say 1,000 hours or so. Now for polypropylene and TPE, they've gone up to 3,500 hours to 5,000 hours. For ABS, nylon and polycarbonate and engineering plastics, they were earlier less than 800 hours. But now all the large OEMs, they are expecting everything to pass more than 1,200 hours. So it's becoming more and more difficult. But then it's important to know what the exact requirement is. and we also need to specify what the irradiance or the location of the part is, where it is going to be used. We know plastics are getting a very bad name. Actually, littering should be getting a bad name, but unfortunately, we cannot change the habit of the people, so we'll have to probably move to making the plastic more and more biodegradable, so that it gets absorbed by the earth as a component of what is going to get reused. There are various ways of bringing about biodegradation. It could be through photodegradation by using the exact opposite of what a UV stabilizer does. You have the UV light actually break down the molecule of the polymer and cause the degradation. There's photooxo degradation by, where you have the reaction starting because of the UV light, and then oxidative degradation by consuming it by having some thermal reaction. On the other hand, there's only thermal oxidative degradation which can be done through composting. And then there are starch-based master batches available with starch-based materials. Usually all these master batches, when they are used in a film, the film is still recyclable, and the product can be designed to start biodegrading maybe in 9 months, 12 months, 18 months, whatever the requirement is or the stipulation by the government authority is. Moving on to the new buzzword, which is nanomaterials. There are a number of nanomaterials available, and we have so many new opportunities coming up where they can be used. For electrical conductivity, there are nanotube based master batches, carbon nanotube, which can be single walled or multi-walled. For thermal conductivity, there are again carbon nanotubes available. There are nanographites available. Even nanographites, you can actually have colloidal form, you can have in powder form, lots of other possibilities with nanographite. There's thermal insulation, which you can get from nanotalc and from nanographite. Again, nanographite is a very tricky material. At a certain size, say between 10 to 30 nanometers, it behaves different. Between 90 nanometers to 120 nanometers, it behaves different, giving a completely different property. And for mechanical strength, we can have nanotalc and nanoclay master batches. For antimicrobial properties, we are already using nanosilver master batches. For flame retardants, there are now nanoclays. There is nanomagnesium hydroxide and a multitude of different materials. We've seen very good barrier property improvement with nanoclays and other nanomaterials. So that brings us to the end of our whole journey with additive and color master batches, and which brings us to the conclusion that with lesser and lesser work being done in making new commercial level polymers, it is very important for us to work towards making more and more additives and master batches which can actually improve the life and the properties of these existing materials. And this can only be done by developing new additives and additive delivery systems. I'd like to take the opportunity to thank IPI for giving us the opportunity to present here about such an important topic, that is color and additive master batches. And if you have any questions, you can approach us at this email address, at this website. And you can always consider us as a consistent, competitive and innovative source for all your master batch needs. Thank you.